Welcome to the Big Bear Math channel and our 5-minute video on writing the equation of a tangent line. In the next 5 minutes, we're going to cover exactly what you need to know on the AP Calculus exam with regards to writing the equation of a tangent line. Now I tell you what, AP Calculus is indeed a bear of a course, and it's time for us to go tackle some bears. Now first things first, I think it's really important to be able to visualize what we're actually trying to accomplish so that we have some real long-term success with this topic. They're going to give us the equation of some function. So this purple graph here represents my random f of x, and they're going to pick a random point here called the point of tangency. And I'm going to go ahead and I'm going to drag my arrow over here. So right there is the point of tangency. And what we're going to do is we're going to try to write the equation of this green line here. And we're going to focus on the two ingredients you need every time. The first thing I want you to do anytime you read a question where they ask you to write the equation of a tangent line is I want you to write down your generic point-slope form of a linear equation. Y minus y sub 1 equals the slope times the quantity x minus x sub 1. And basically what's going to happen is you're going to put a number right here, and right here. And if you can fill those three spots with numbers, you're in good shape. So here's exactly what we need to find. Number one, we always need to find the curve's y-coordinate at the point of tangency. And number two, we always need to find the curve's instantaneous slope at that point. So assuming that the curve that they've given us is f of x, we'll just call that the generic name for that purple curve we saw. How do you find the y-coordinate? Well, what we're going to do is we're going to evaluate the original function at point A, assuming that point A represents the point of tangency. And number two, more importantly here with regards to calculus anyways, how do I find the slope? First thing we're going to do is we're going to find f's derivative in terms of x, and then what we're going to do is we're going to evaluate that derivative at point A, and that number right there is my slope. Okay, here's our first live example, and we're going to try to put everything we just talked about into practice. And so let's say they gave us a random function, f of x equals the square root of 2x squared plus 7. That's a squared. And they want us to evaluate or write the equation of the line tangent to that curve at the point when x equals 3. So x equals 3. So the first things first, let's go find our y-coordinate. And so I'm just going to kind of organize my thoughts right here. I'm going to go find my y-coordinate. All I'm going to do is I'm going to evaluate the original function at the point of tangency, which happens to be 3. And if I plug a 3 in there, I think I end up with radical 25, or in other words, we could say that f of 3 is really a 5. Alright, number two, we need to go find the slope. And this is the most important part because this is the part that really it's the essence of what calculus is really about. Now the derivative is going to require the use of the chain rule. So if that's a little bit new to you, we might want to go pick up another video on the Big Bear Math channel. But the chain rule says we're going to derive the outer function, which was the quantity raised to the 1/2 power. Leave the inner function alone, subtract 1 from that exponent, and then don't forget to multiply by the derivative of the inner function, and that's where the 4x comes from. Now I'm really not going to spend much time trying to clean up that derivative. I'm just going to evaluate it at 3. And let's see, we get 1/2, and then we get 25 raised to the negative 1/2, and then I get a 12. Now 25 raised to the negative 1/2 is like the 1 over the square root of 25. So that's going to turn out to be 1/5, and then we got to multiply by our 12. That turns out to be 12/10, which reduces to 6/5, but you actually don't have to reduce it. And then let's finish it off. Let's put it all together now. We're picturing the point-slope form of an equation, and we're going to plug in our key ingredients here. And we could say y minus 5, that was my y-coordinate up here, equals the slope, which is 6/5, times the quantity x minus 3. And the best news of the whole night is the AP exam does not require us to clean that up. You don't have to distribute. You don't have to solve for y. Ladies and gentlemen, they're going to accept this answer right here.